everyone go ahead and work on this warm-up. You can do it on the back of your homework packet. And go ahead and pause the video because I'm going to go ahead and go over them. So for the first one here, you should have gotten length BC. If you remember, when you have a triangle, and I label it ABC, angle B is 72. Obviously, this is not drawn to scale. Angle C is 28. I need to know all the angles of the triangle so that I know where the longest angle is. So if I take my calculator and I do 180 degrees in a triangle, take away 28 and 72, I can see I have 80 degrees left here. So that means that the longest side is going to be opposite that biggest angle, so that's why it's BC. The second one, whoops, that I have here, I should have gotten angle A. So if I make my triangle again, I have AC is 20, AB is 14, and BC is 12. And they want to know which angle is the smallest. Well, the smallest side is CB. That means angle A will be the smallest. And then 3, if two sides of a triangle have lengths of 20 and 26, what is the possible length of the third side? So my solution here is 30. And remember, the two smallest sides have to add up to be more than the third side. So if I take 20 plus 26, that gives me 46. So that's why it can't be this one. It definitely can't be this one. Well, why doesn't 6 work? Well, if I take 20 and I add it to 6, those being the smallest two, that would equal 26. And it's got to be bigger than that third side. So that one won't work at all. So it's got to be 30. Here are your homework answers. Once again, would you pause the video and check those? I'm going to keep on going. All right, and if we have any questions about that homework, you're welcome to ask me when I return. So the day 10 notes are going to be about the sum of the angles in a polygon. So a polygon is a closed plane figure with at least 3 sides that are segments. The sides intersect only at their endpoints, and no adjacent sides are collinear, meaning they're not on the same line. So on the bottom here, this first one on the left is a polygon. The one in the middle is not a polygon because it's not closed, right? I don't have a segment from A to E. And then this middle one, or excuse me, the last one is not a polygon because as you can see here, these two segments are crossing and they only can intersect at their endpoints. So that is not a polygon. We're going to focus our conversations on convex polygons, which means it has no diagonals with points that are outside the polygon. So if I look here, these diagonals are all going to be inside. And you can also see that all these angles pop outwards. A concave polygon has at least one diagonal with points outside the polygon. So from M to W, this diagonal is outside. And then you can see that these angles go inwards, and we're not going to focus on those, but those are called concave polygons. We all know that the sum of the angles of a triangle is 180 degrees, and those are the interior angles. We're now going to use this idea to come up with a formula for the number of degrees of the interior angles of any convex polygon. So how are we going to do this? We're going to take our straight edge, so hopefully you have a straight edge at the side of your calculator, and from one vertex, we are going to make a diagonal. So right now, I have 2 triangles, 1, 2. So my 4-sided shape, which is called a quadrilateral, has 2 triangles. So that's easy. 2 triangles 2 times 180 degrees for each triangle, I have an interior sum of 360. All right, the pentagon. We'll do the same thing. Pick a vertex. I'm going to pick this one here and draw in every diagonal you can to make triangles. So I have 1, 2, 3 triangles. So I have 5 sides. This is called a pentagon. I made 3 triangles. 3 times 180 degrees is 540 degrees. And I'm going to keep doing this until I notice a pattern. All right, I've got 6 sides now, so I'm going to draw my diagonals in. I've got a diagonal here, here, and here. So I have 1, 2, 3, 4 triangles. So 6 sides. This is called a hexagon. I made 4 triangles. 4 times 180. Whoa, my calculator is super small. How did I make it so small? There we go. Gives me 720. And that's degrees. And I'm going to keep on going. So connect. Whoops, what am I doing? Same vertex. Connect, connect, and connect. So I have 1, 2, 3, 4, 5 triangles, but I have 7 sides. So 7 sides is called a heptagon. I have 5 triangles, so now I'm going to do 5 times 180 degrees, which is 900. All right, moving on. So now I have 8 sides. So I'm going to connect my diagonals, and this might be getting redundant because you might have seen the pattern already. 1, 2, 3, 4, 5, 6. So 8 sides is an octagon. Octagon, right? That's an A. Yeah, octagon. And I have 6 triangles. So 6 times 180 is 1080. And that's it in terms of pictures, but we should know that 9 sides is called a nonagon. 10 sides is a decagon. And 12 sides is a dodecagon. So just a few more that are good to know. Okay, so look back, and do you see a relationship between the number of triangles and the number of sides? You should have noticed that the number of triangles is always 2 less than the number of sides. So to figure out the sum of the interior angles, all we have to do is multiply the number of sides, which is n, minus 2 times 180 degrees. And that will always give me the number of degrees of the polygon. So let's try this. So we're going to try to figure out the measure of angle A. So right now, this shape I have is 4 sides. That's a quadrilateral. You might know already, but let's practice using the formula. So I have 4 sides minus 2 times 180 degrees. And that 4 minus 2 is like those 2 triangles that I was able to form. So I have 360 degrees. So now I'm going to take all the angles in this quadrilateral and subtract them from 360. Well, if this angle is 70, it's supplementary to this one, so this is 110. So I've got 110 plus 110 plus 20. So I have 240. 360, take away 240, gives me 120 degrees. So A is 120 degrees. The next one, we're going to fill in that this is 80 degrees. And let's see here, I've got 1, 2, 3, 4, 5. It's a pentagon. So I'm going to do n minus 2 times 180 degrees to find out how many degrees in the whole pentagon. 5 minus 2 times 180 degrees. So 3 times 180 degrees gives me 540 degrees. All right, let's see what I have here. Well, I have the 152 and the 63. What is this angle here? It's supplementary to 60. So this is 120. This angle is 80. This must be 100. So I'm going to take all those angles and add them up. So I have 120 plus 100 plus 63 plus 152. I got 435. So 540 minus 435. So angle B must be 105 degrees. Three. I'm going to fill in 140 there. And I can see that this angle C is also here and here because of the congruency marks. All right, how many degrees altogether? Well, I have 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180 degrees. 4 times 180 degrees is, oh, let's see, what was this one? 720. So I have 720 degrees. And that is supposed to equal 3C plus, and now I'm going to add up the 140, the 76, and the 84. And that's 300. So I'm going to take away the 300. 3C equals 420 divided by 3. C is, I believe that's 140. So C is 140 degrees. Oops. All right, our next one here. Fill in 83 there. And at this point, why don't you pause the video and try this one on your own? I'm going to go ahead and jump right into it. But there's several ways to do this problem. I know we have 90 degrees here. I have 1, 2, 3, 4, 5 sides here. So 5 times, or minus 2 times 180, 3 times 180 is 540. So from that 540 now, I'm going to figure out, let's see, 72 plus 83 plus 110 plus 137. And I'm going to take that away from 540. And that gives me 138. So D is 138. But now I still have to figure out E. Well, I know that this must be 70 degrees. And these two angles are supplementary. So 180 minus 83 is 97. So I have two ways to figure out angle E. I could look at this entire polygon, or I can look at this quadrilateral with 4 sides. So if I look at the quadrilateral with 4 sides, I'm just going to add up the 90 plus the 97 plus the 70, and I'll take that away from, you probably remember this one, 360. And I get 103 degrees. And I did it. 5. Just throwing in a little more algebra. So how many degrees are supposed to be in the interior of this polygon? Well, it's 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180. 4 times 180 degrees, 720. And now I have to add up all these angles. So let's see, I've got 8x, 10x, 11x, 19x, 20x. And I've got to add up the numbers. So I've got 1, 33, 34. This knocks me down to 30, 27, 20. And now I can solve. So subtract the 20. Divide by 20. So we got 700 divided by 20, 35. So my x value is 35. I don't remember. Do they want me to find something else? Nope. I think they just want me to find x, so I'm good. All right, so your homework tonight is to do the day 10. If you do finish that early, you're welcome to start working on the Delta Math for your next skills quiz. All right, have a great day, everyone. Bye.